Yeah. So the manual has all the different features you want to look for. If you want to find anything with regards to the manual, the documentation for MySQL is you just Google MySQL manual, and then you'll find all the stuff. You're using version 8 point something, 8.0 of the server, and you can find all the features, all details you could ever want to ask for. It's in here. So I say I can actually remember MySQL date range. That's where Stack Overflow really helps, because I can't remember. So it looks like between actually works. Let's try that. So we want to find all the tasks where created is between the, let's just say, the 20th of September 2017 until the 5th of October. So what would I do here if I had to use the between method, or any method basically?
Particular about the dates, right? So created of like month.
Yeah, before we did this thing, right? It said year is 2017 and month is 9. But here we want not a specific month, but we want something that goes across 2 months. We want like October 20th to, sorry, September 20th to October 5th. Let's say that. So we have to use where created any suggestions? Yeah.
Then date.
I can't actually remember how to do that. It's and, okay.
And date.
Yeah. 17. Oh. Let's try. Let's see if that works. Yeah. It does. It works fine. I think we can also do something else. Like, I haven't actually done this in a long time, so let's try it. I think you can use, like, you know, in JavaScript when you want to say I is greater than 5 or whatever. I think we can do the same here with dates, but I'm not sure. So let's try it. Where created above. See if this works. I'm not sure that it does, so let's get ready for it to fail if it doesn't work. Yeah, that works as well. So you can do the greater than or smaller than or equals and all that stuff on date values in the database as well.
What's the command to comment?
To comment is just dash and then a space.
When you select the text and then comment.
Ah, yeah, you can do, so if you select some text, you do Control-Shift-7.
It's on Linux.
Yeah, on Linux, yeah, I think it's the same on Windows, and I don't know what it is in Mac. It's usually the same in like editors for...
Control-Shift-7?
Yeah. Maybe in Mac it's like Command 7 or something. I'm not really a Mac.
Control-Shift
7?
7.
Yeah, the number 7. I don't. Usually it's the same I use in like Visual Studio and stuff. I don't know what it is on a Mac. Okay, let's do. Let's find the amount of days between a task was created and the due date. And again, I am very forgetful. So I use Google because that always works. So we can use the date diff function, right? So let's try that. Let's try it. So then we say select. Oh, we actually want to select, but we want to select the difference between the created and the due date in days. So if you read the documentation here, it's a bit hard to see. Now it's lagging. I think it's because it's recording and really. There we go. This is the function I would use if we want to find, because the documentation says from the first and the second parameter expressed as a value in days from one date to the other. Only the date parts of the values are used in calculation. So it ignores the time, it only uses the date. You can see some examples of it here. There we go. So this is the example that they use. So how would we do it here? So let's just we can do this and see what results we get. So we do it here. I mean, not all of them have a due date. Yes. There we go. Okay. So now we want to find the difference between created and due date. So how would I do that?
The difference in the time?
Yeah, the number of days between it was created and when it's supposed to be finished.
Difference and?
So the documentation for this is, so we have to use this function, the date diff function.
Date diff, yeah.
And what do I put in here? Yeah, we can give it a name as task duration, let's say. Yes. So all these are negative. So how come? Yeah. Switch them around. Because the due date is the biggest value. Perfect, yeah. Now you can see the number of days between 87, 85, 86, all that stuff. And there are a lot of these, I can link this in here. There's a lot of these functions in the manual. These are specific to date and time. I can basically just go one level up. So you have all the operators and all the functions listed in the manual here. I will just link that in Slack. Thank you for the photo. Let's do one more query and then keep the pressure on Fleming.
Try includes IN.
Hey, what's sorry?
IN.
In. Yeah, we can do that. So
Yeah, similar names.
let's say we want. So you mean the in, like where X in something?
Yeah, something like
Yeah. Okay.
includes like some letter, some strings.
Yeah. Usually, what you do is you use it for if you have a set of values. So let's say that on the front end you have a list of all the users, and the user can click, on and off all the users in the table, and you want to go back to the database and say, give me all the users that are in this list of IDs. So what you could do is you say select star from user where ID in, and then you give it a list of values. So if we can run this first, this just gives us all the users, and then say where ID in, let's say 1, 3, 6, 7. That just gives you those users. One thing you can do is, instead of a list of values that you hard code here, you can also put another query in here. So let's say this is not the best way of doing it, but let's say just for the sake of argument, we want to find all the users that have at least one task. So what you can do is, so because this only returns one result, you can use this as a set in this in condition. There we go. So now you'll find all the users that have at least one task. But actually this is not the most efficient way of doing it, because if we run this query by itself, let's try and run this by itself. We have things that come more than once, right? So we're actually fetching 46 rows, but some of them are the same value, 111, 222, 3333, whatever. What we can do is we write distinct. Yeah, exactly. Distinct just means give me the unique values of user ID. So if there's a value that goes again more than once, just throw that away and only have the unique values. So here we only get 11 rows. So, and now if it's between 20 and 11 rows, you're not going to see a difference. But imagine that this was a database with 6 million users in it, and you could eliminate 2 million rows or whatever by doing this. Then it's a really good thing to do. As like a rule, you only want to fetch the data that you're actually going to use for something. So if you have in the front end, if you have a list of users and you only show the user ID and the user name, but you don't show the phone number and the email, then there's no reason to fetch the phone number and the email. So just only fetch, sorry, that was me. You only fetch the data that you actually use in the front end. That's usually like a good thing to do.
Alright, I'm done.
Cool.
Should I just upload it to Slack?
Yes. Update ikke noget til noget?
Nej, det giver mig den bare sådan.
Cool. So now we'll have our class database. Slack. There it is.
Oh my god, right.
Yes.
Otherwise we can spot the mistakes.
Yeah.
Otherwise no ice cream.
Yeah. Yeah.
Cool. Let's make a new database just for this and call it
Yeah, I call it HYF student database, but
yeah, students HYF.
Also, one thing I did change was I made the table names, what's it called, non-singular form, so plural.
The users and
yeah, it's just a convention I'm used to.
So yes. There we go. So let's try and file this thing off. This will go up. Yes. So now we have. Come on.
Can we do the EML?
Yeah, we can do. So now we have the database version engineer. HYF. Next. Oh. Next. Close. There we go. So now we have the. Just reorganize this a little bit so we can actually. What do we have here? Class. See if I can have the same as on the board. There we go. So now we have the one we had on the board. So we have that here now in the ER diagram editor. So it should be the same as we have up there, or the database version of that. So if we wanted to start querying this, we could, and you can go all the way from, because all these tables are related to each other, you can go all the way from students to lectures if you join. So you could potentially join students with classes, join classes with class courses, join class courses with courses, and join courses with lectures. And you can go all the way from an individual student to whatever homework they're supposed to do for the next Sunday. What the curriculum is, you know, what books, what links, all that stuff for this. And you can see this could be used as a calendar thing from and to for every course, and with the just gonna wait until the noise is gone.
It might have been a bit overkill to make it a date time in that table in the middle, but I just did it to show the difference.
Yeah,
it's a date on the lecture table, but
yeah. The difference is if it's a date, it only contains year, month, and day, and if it's date time, it also contains the time, 12:04, whatever it is.
And I also made one of the foreign keys nullable. It's the class ID on the students table, because you could imagine that once you get into Hack Your Future, you're not assigned to a class yet, so that will be null for that time. Or if a class for some reason gets cancelled, or I don't know, then if you delete from that table, you won't delete the student.
Yeah, we have more next time about how to construct tables. So all the magic he did to make this table, we're going to cover that next time. So it's not going to be magic anymore. It's going to be, you're going to be able to do it yourself. So we could actually just insert a couple of values in this database and then make an example query all the way from students to lectures. Let's just I'm just going to put in like one row in each table or something like that. Let's just try this here. Tables. I have to start with students, right? Yes. Select rows. There's no like an easy insert thing here. No, there isn't, is there? No, there's not. Okay, perfect. Use HYF4. I'm just going to quickly insert some data. So this might seem like a mumbo jumbo, but we're going to cover that next time. So then we have classes. Let's call it Class05. See you guys. Then actually we would need to change this to 1. Cool. Then we need a course. Then say class courses. Let's say 2018. Let's see if this works. Then we need a lecture. Then we see here lectures, columns, any date. So curriculum, blah blah, homework, blah blah, course ID, I guess that's one. Yes. Perfect. Now we should have some data in each table. So let's see if we can select all the way from students to lectures. We want the name of the student and the name of the course, the name of the class, and the date for the lecture. So maybe we can we have this up in 2? No, we can't, can we? Maybe I can do this.
Maybe take a screenshot and put it on.
Oh, I think it's okay. Maybe we can. Actually, maybe we should just. I can do it in now. And here instead. Can we? Can I zoom in this one? No, I can't. Zoom in that one. I think I can do it in this one. So, here we go. Let's select all the way from student to lectures. So, I'm just going to write the first line of it. Select. Select student and name. Oh, students, I guess. Class is the name. Course is the title. Lecture is the date. From. So how would I start out this query. Go all the way from students in the bottom left to lectures. Sorry? Student? Yeah. Inner join on what? Classes, yeah. And then, sorry?
Student ID, class ID, class ID.
Oh. Like this?
Yeah.
Okay. And then how do we get from classes to courses? Actually, we have to get from classes to class courses and from class courses to courses. It looks like this one. That's the hint. Yeah, inner join again, yeah. Like this. So what's common between classes and class courses? Yes. So we say class. Oh. Shit. Now we're awake. Class ID equals. Oh, I need an on here. Should be equal to what?
Classes.
Yes. And then how do I get from class courses to courses? Yes. On what? On? What are you?
Lectures.
We're not on lectures. So here we're trying to get from class courses to courses.
The right one, yeah.
So you have to find the common, what's common between these two.
Course ID.
Yes, exactly. So yes. And then can you get with the last one? On? Equals what? Lectures dot course ID. So you can actually turn it whatever way you want, as far as I know.
Yeah, it doesn't matter.
We can do that.
Yeah, here in the on clause, it doesn't matter which one it is. You can do whatever order you want. I usually just use the same order all the way down because it makes it easier to have an order.
One thing we didn't mention is you can actually have multiple statements, just like with the where statement. So you can say and, but it's not so used.
Can you just one in a join and then
No, not in that way. But if you have two columns that need to match in the same table.
Yeah.
So, but it's rarely used, I think.
Yeah. Let's see if this works. Think it's gonna blow up, or do you think it's gonna work? Let's see. Yes, it works. So we went all the way from here to here to here to here to here, just through the relations between the tables. And you can have. Let's see if we can find. Just to scare you a little bit. See if we can find something here. Something that can scare you away. I don't know what this is, Portal. Maybe this one is. I don't know.
But it can be quite.
Here's a nice one.
Sometimes.
Oh, open image in
Next one.
This one is.
But it's not uncommon to have that many tables.
You see, this is the same. It's a little bit different color and everything, but this is also just a database diagram.
It's going on for you.
Yeah. Maybe, I don't know if it's going to.
All of these tables.
Yeah, they're all tables, and they are all related in some way. Some of them are isolated, like you see the bottom.
Those in there.
Yeah, it looks like a metro map. Yeah. So, like you see the right-hand corner down here. Maybe it's a bit hard to see, but they don't have any connections outside of this little square down here. But many of the other ones have like connections all the way to the rest of the database. So as long as you have a connection, you can keep traveling all the way, you know, around the system, around the databases. I had when I was in university a long time ago, I had a teacher from Brazil, and he used to work in a bank in Brazil where they had a database that was quite big. And he said that when he started working there, they had a room kind of like this room with like a board that would cover the whole wall, so like this wall over here behind you with the windows, and it would have a diagram with like ER diagram with boxes this size, and it was filled with an ER diagram. That was just the whole one side of the room was just the how the database was structured for the bank, for his bank that he was working in, because it had been, you know, done since the 70s, and they just kept adding and adding and adding and adding. So yeah, it can be everything from the most simple database to 500 tables that are all related. Yes. Let's see if we can come back here. Yeah.
It's a good thing to do these diagrams to have an overview of the database, and you can go in and tweak all the things before you start actually implementing, so you are sure that it's what you need to create.
To have an idea what we're doing.
Yeah. It's also when you're like, so like when we were doing the doodling on the board up there, you impose some restrictions on the organization, and usually you want to map the organizations correctly, and saying that a student can only be in one class, you can't be in two classes, for example, or you can't be different, like what do you call it? The course has to have minimum one lecture and all this stuff. But let's say then we design this application, we build it, and everything is fine, everything works. And then suddenly Christopher comes in and says, oh, by the way, I have a new idea. Let's have before lunch classes and after lunch classes on Sundays. And then suddenly one student can be in two classes. Because you can come here for database stuff like from 8 to 12. Then you eat lunch, and then you can do whatever, React, Node.js stuff after lunch. And then suddenly the assumptions that we made about the database, or about the assumptions we made about the system here, no longer fits with the database.
Like new design.
Yeah, and then you have to redesign the database and say, well, now a student is no longer limited to only being a member of one class, they can actually be in two classes, or 3 or 4 or whatever. So then you have to edit the database and alter the database to make it fit within the new worldview, so to speak, in the organization. And that happens a lot when you're designing stuff for applications and organizations and whatever, and then you'll get to know, oh yeah, this is the way it is, and it will always be like this. And then 2 months later, the manager comes in and says, oh, by the way, can you change this basic assumption about everything? And then you have to go and redesign the database and redesign all the UI and the front end, just because someone figured out that, well, we want to be able to be a member of 2 classes or 3, whatever it is. So that's also the structure of the database forces you to specify the data format when you design it, and the people who use your database have to, as I said before, they can't break the rules, because you're just going to get an error message if you try. It's not possible. So
that's a good thing.
Yeah, that's a good thing. We can try it here. If I maybe I can actually. say I want to have into lectures. Let's say I want to insert something. We haven't covered inserting data yet. We're going to cover that next time. But lectures. Let's say I try to input something that's invalid into this database. Where to go? Students. There it is, lectures. So this is what I'm trying to insert into this database. I'm trying to insert something where the course, into the lecture table, where the course ID is null, for example. Let's try and insert that. I will just get an error message saying column course ID cannot be null. It's just going to fail.
You could also, yeah, exactly.
Yeah, I'll put in a course that doesn't exist, because I know we only have one course in the database. That course has ID 1. Let's try and insert something that's not there. It's going to say, it's a bit hard to read, but it basically says is a foreign key constraint fails, which is this is a foreign key, this course ID, and I tried to put something in there that's not in the table it points to, so sorry, you can't do that. And that's always going to be the case. You can't break the rules. Cool. I don't know if we have anything else. Anything missing? Any questions?
Whatever, like the one we were using before was non-relational
JSON file?
Yeah, is it non-relational?
Yeah, it's just a flat file basically. It's like a CSV file or an Excel file or whatever. You're just saving raw data on the disk as, formatted as JSON. But in that, you could. So there's another type of databases that you can use, which are called. I think the common name for them is NoSQL databases. Something like MongoDB or CouchDB, or I think Postgres has like a JSON object storage as well, where you can just throw some JSON in it, and then it will save it for you, and it will be very fast. But there is no schema. There's no rules for what you can save. So let's say that you are making an app that uses the same database, and then you start inserting objects into this NoSQL database with some column missing, and your application can handle that column is missing. But then he starts making some stuff based on the fact that he thinks that column is always there. And because the database doesn't enforce you to a worldview where it says this column is always there, then you can basically do what you want. You can put in a class as a student or a student as a class, and you can add as many columns as you want, and you can break the rules because there are no rules. It's a lot faster for certain things, but it also it makes it easier for some workload or for some projects for you to iterate and not have to think so much about database design. But for example, I know that this was in the beginning at least. I know something like Twitter used something like object storage. Like, I don't know if they used exactly MongoDB, I don't think so, but they used something like it because you would use it for a tweet, and the tweet would point to other tweets and retweets and all that stuff. Where if you try to retweet a tweet that doesn't exist, then what's the big? It doesn't work, but it's not the end of the world. But let's say that you're a bank and you have customers' money stored in this database, and then you want to make sure, 100% absolutely sure, that all the columns are defined and it's pretty locked down what can be in those columns and what the value means and no one that comes into your database can just assume stuff about the database and put new columns in and remove columns and stuff. So the databases, different types of databases are good for different things. That's the.
Are there also any security concerns? Like, are there like SQL is like better with the?
I think SQL has been around for a longer time, since the 70s. I think. I think that was when it was. Yeah, I think the 70s or something, early 70s, and it's still like I think every company I have worked for in the last. Yeah, I graduated in 2006, and every company I've worked for since then have used some form of SQL database. Some of them recently have also started using MongoDB, CouchDB, and all these other things, but they all, for at least some features, use an SQL database. I worked at Spotify for a year and a half. They used Postgres for their user database, and I think also for their playlists. And I've worked for other companies that did like Netflix kind of stuff, and they were using MySQL. Working for an accounting company, and they use Microsoft SQL for different things. So even if SQL is old-fashioned, it's still used everywhere. Yeah, I wouldn't say better, but it's used everywhere, and it's good for different things. Because it depends on the requirements for what you're building. If you want to use MySQL or MongoDB or Postgres or whatever.
But there is some aspect of security in those rules that the database enforces compared to the other types. So in that way you could say it's maybe more secure, but it depends on what you're building.
Yeah. Next time we're gonna cover something called SQL injection as well. I don't know if anyone has heard of it. Yeah, it's a way of attacking a database, basically. You know, if you've ever seen, all these security leaks, LinkedIn got their database leaked. I think Dropbox did as well. Some other big companies, they got database leaks out into the internet. That usually comes from SQL injection. It is that. So when you write, we're going to cover it more next time. But let's say we have a query here where we say select star from user. Query that you could imagine comes from some sort of web front end or something, right? Next time we're also going to show you how you can connect to MySQL from Node.js. So let's say it comes from there. And you put in 1. But then instead of 1, the end user actually puts in 1 drop table user. So they put in, instead of 1, they put in 1 semicolon drop table user semicolon. Then when the server runs that, it's going to delete the user table. So that the basic principle is never trust the user, because users are not trustworthy, and they can put in whatever they want into a field in a web browser or an application on their phone, whatever. And there are some examples of banks and other more, organizations that should be secure, and they are not. There was I don't know if you know, like digital money kind of concepts. Not like Bitcoin or stuff, but stuff like digital money in that you can log into, like mobile pay, for example. Mobile pay, we have in demo, you send money back and forth when you split the bill at a restaurant, or pay some money to your brother or whatever. So there was back in 2002, 2003, I think it was, there was a Danish project called e-kroner or e-money or something like that in Denmark. And they were doing kind of like what mobile pay is, except that it was just on in the browser. It was before the smartphone and stuff. And you could send money back and forth, and I could send 20 kroner to you, and you could send it to him, and it was just, you could do that. And it relied on a central database that was running Microsoft SQL Server. But what they hadn't thought about was that they had exposed that database to to the whole world, because anyone could write whatever they wanted into the database when they were logging in, I think it was. And then someone actually posted up on a Danish forum saying, well, it looks like this system is vulnerable, so if you click this link, then it's going to delete the entire database of this online money banking thing. And so he posted a link on a forum and then didn't do anything. And then someone else came by and thought, that's got to be bullshit. And then he clicked the link, and then he deleted the entire database of that company. And delete database, shut down database. And do you know who got I think he got a fine for doing it. Do you think it was the guy who wrote the link or the guy who clicked the link?
The guy who wrote the link.
No, the guy who clicked the link. Yes. Because it said right next to the link what it would do. And I think they compared it to, a robbery. I can say like, well, you could rob this bank easily because the door is open. And then someone actually goes in and robs the bank, Like he didn't get any money from it, but still he brought down this whole system just by clicking a link in a browser. So yeah, security is important. Especially if you're doing money or banking or...
So more database, and you should use more authentication.
Both that, but you should also make sure that the input you get from your users, that you validate that input. So if someone puts in a birth date, for example, saying, well, when is your birthday? If you want to show their age on the website, whatever. Well, then you make sure that they actually put in a date, not a string or a number or a decimal or,
Validation.
Yeah, you validate everything. We can show you next time how you do that in Node.js. Yeah. I think we only have 20 minutes left, so I think we can just get started on the homework, and then if you have any more questions, just let us know, and we can walk around and poke at you, see if everything is working. And there is for the next class, let's see if we can find it. I don't know if you noticed this, but there's something called pre-class readings. There are links to lynda.com. It's a service that costs money. You can sign up for a trial account and then cancel it, but you don't need to do that. These are just optional videos that you can watch if you want to prepare. But make note that if you try to sign up and you forget to unsubscribe, then they will charge your credit card. So, it's not required reading. These reference materials are pretty good to read beforehand. You're not going to read the entire MySQL manual because that's thousands of pages of stuff. Just have a look through them. For lesson 2, we're going to cover about how to create tables, how to insert and delete stuff, and how to connect to it from Node.js. There's this article called the Asset Database Model, which is really good to read before the next class. It's not a very long article. It's like maybe like a couple of 2 pages or something. Yeah, not that long. To get an understanding about how databases work and what properties they have. The other one is just how to connect to MySQL from Node.js. We're going to cover that next time. Yeah, there are also some more material you can. Don't read through it all. Just click the links and glance through them and see what they contain. Cool.